Hey, there's one last cubic unit cell we're going to look at, and this is probably the most important one because this has the highest packing efficiency of any cubic unit cell. This is actually 74% efficient at packing. So this is the face-centered cubic, or FCC, and if you're wondering where CCP comes from, this is cubic closest pack. So this lets us know that this is the closest way to pack spheres in a cubic unit cell. In fact, if you ever pack oranges at, say, the grocery store, you're probably packing things using this kind of unit cell. It's got this cubic base structure here. So here's my cube, and hopefully you're good at drawing cubes, better than me. So you've got your 8 lattice points at the 8 corners, right? These are probably where your atoms would be in an element, let's say. And what makes this face-centered cubic is that each face, so each flat outside, there is a atom. So I'm going to go ahead and draw a line from left-hand face to the right-hand face, the top-hand face to the bottom face. Okay, and from the front face to the back face. And so hopefully you can kind of make sense of this structure here. I'll draw a three-dimensional pic. Well, I won't draw one. I'll show you a video of a three-dimensional structure here. Hopefully it's easier to see when I rotate it where they are. But if we want to go ahead and ask ourselves how many atoms would be inside this unit cell, we have to know how to handle the face. And it turns out that each face atom, so this is what we call these are faces, and only 1/2 of the atom is actually inside the unit cell, 1/2 is outside. And if you imagine taking two cubes next to one another, right, the atom at the faces would be shared 50% in one, 50% in the other. So what do we have here in terms of number of atoms? We've got the 8 at the corners, and only 1/8 of the atom at a corner is inside the unit cell. You've got 6 faces on a cube. Remember, half of the atom at each face is inside, and so that gives you a total of 4 atoms inside the unit cell here. So if we are packing atoms. And what are some things that pack like this? Pretty much anything other than the examples I've given you before. So this is a unit cell for the face-centered cubic, or the cubic closest pack structure. You can see there is an atom at the front and the back, the left and the right, and the top and the bottom face. You can see half of that atom's inside, half of the atom is outside the unit cell, plus the 8 at the corners. We can go ahead and we can make 8 copies of that. Actually, we'll go ahead and make them large first. You can see this has the absolute best packing. So was it 74% of all the space I think is used up here. We can make 8 copies and it looks something like this. You can see they start to line up in planes, intricate fashions, and we can actually figure out where they are by scattering x-rays on it. Again, if we go ahead and we make the lattice points a little bit bigger, you can see there's not a lot of empty space in there, but you start to see these rows, these planes of atoms. And we'll go ahead and we'll make a bigger cube, something like a nanometer by a nanometer by a nanometer. So this is a tiny little portion of copper, and you can see all the atoms are nicely lined up, not a lot of empty space. And if you ever go to the grocery store and you look at how they pack oranges, they pack it this exact same way. This is the cubic closest pack, the most efficient way to pack spheres in 3 dimensions.